Alright, this video is for the Unit 7 portion of your final exam review. Unit 7 was solving quadratics. You're allowed to use your calculator for these questions. Alright, so first solve by factoring. Problem 1 is 36x squared minus 25. There's two terms here. There's no GCF, so we're going to factor by the difference of squares. The square root of 36x squared is 6x, and the square root of 25 is 5. So it'll be 6x minus 5 times 6x plus 5 equals 0. Now, in order to solve by factoring, you have to use the zero product law. And the zero product law says that you can take each of these factors and set them equal to 0. And if you solve the two little mini equations we have now, you will have the solutions to the quadratic. So on the left one, if I add 5, I'll have 6x equals 5 and divide. One solution will be positive 5 over 6. And on the other side, I'll start by subtracting and then divide by 6. So our other solution is negative 5 over 6. Two rational answers for that one. Number 2, I have 3x squared plus 2x equals 8. Now, in order to solve by factoring, our quadratic has to be set equal to 0. So I'm going to start by subtracting 8 from both sides. I'll now have 3x squared plus 2x minus 8 equals 0. Now I have a trinomial, which I can factor by splitting the middle. 3 and negative 8 multiplied to negative 24. Two numbers that multiply to negative 24 and add to 2 are 6 and negative 4. When I split the middle here, I'll have 3x squared plus 6x minus 4x minus 8. I'm going to group and pull out the GCF for each group. Remember, this is always good because you should notice that the two factors that are in parentheses are still the same. So my final factored form here will be 3x minus 4 times x plus 2. Now, when I set each of those factors equal to 0 using the zero product law, I will be able to find my roots. So if I subtract 2, I get that one root is x equals negative 2. And the other one here, I'll have to add 4 and divide by 3. And the second root is 4/3. Those are the solutions. All right, make sure you can factor difference of squares, trinomials, by grouping, GCF, all the different factoring methods. Remember, this review is just a sample of problems. We're not going to give you one of every single kind possible. Here we're going to solve by completing the square. Also, make sure you can do the quadratic formula. I can use the completing the square here because the leading coefficient in front of the x squared is 1. And the middle term, negative 6, is even. So completing the square is going to be possible. Now, in order to start completing the square, I need to move the 23 to the other side. When I do that, I get x squared minus 6x, and then I put a plus box. I put a plus box on the right side as well. To fill in the box, you take half, I'll do it off to the side here, half of the middle number, and then you square that value, and negative 3 squared is 9. So you completed the square. Now you have to simplify and solve for x. The right-hand side is easy. Negative 3 plus 9 is negative 14. Negative 23 plus 9, is negative 14. The left-hand side, remember, it technically factors into two trinomials that are exactly the same. X minus 3 and x minus 3. Notice that negative 3 is half of negative 6. But we always wrote a little shortcut. We always said, well, since the trinomial or the factors are going to be the same, it's a perfect square trinomial, I can do x minus 3, the quantity squared, since I would write them twice. Now, in order to get x by itself, I have to square root both sides to get rid of the square. X minus 3 equals. Now, with square root here, I have plus or minus. Since there's a negative under the radical, it's I. The square root of 14 doesn't break down otherwise. To finish the problem, you add 3 to both sides, and the plus 3 goes right in front of the plus or minus. So your final answer are the solutions 3 plus or minus I radical 14. Those are the solutions solved by completing the square. All right, a couple multiple choice here for Unit 7. It makes you think a little bit about factoring and solution. It says, what's the product of the roots of x squared minus 4x plus k if one of the roots is 7? All right, now, think about how you would factor this here. If one of the roots is 7, that means it came from a factor of x minus 7, right? I have one of the roots is 7. I have to have negative 7 and something else here. Now, the other factor, look, it has to add to negative 4. And if I have negative 7 and a plus 3, that would give me the middle term of negative 4. Now, if you're not sure, think about foiling this to check your work. X squared plus 3x minus 7x, then we have minus 21, which will give me x squared minus 4x, like we wanted, minus 21. Well, the product of the roots, right? So one of the roots here was 7. The other root from the x plus 3 factor is x equals negative 3. And the product of 7 and 3 is negative 21. So that would be your solution. For number 5, similar type of question. For what value of k will the roots of the quadratic expression shown be real and rational? Now, I gave you a hint here. I said, think about the discriminant. That's the b squared minus 4ac. Remember, that's the part of the quadratic formula that is under the square root. And we learned a long time ago, way back in January, that the discriminant, the part under the radical here, is what tells us what kind of roots we had. We could be rational, we could be irrational, we could be imaginary, or there could be one rational. And we said that if the value, if we wanted rational roots, the discriminant, the value there had to be a perfect square. So we want our discriminant to be a perfect square. So you have to do a little bit of calculating here. If you don't remember this about the discriminant, then I'll show you a different way that you could do this problem in just a second. I'm going to erase this part right here real quick. All right, now, the discriminant here. Remember, discriminant D is a b squared. Well, b is negative 5 minus 4 times a, which is 2, times c, which is k. Well, negative 5 squared is 25. This will be 25 minus 8k. So if I use that formula for the discriminant here, I can plug each of these values in for k and see what kind of value I get. So for a equals, for number 1, for k equals 1, I'll have 25 minus 8 times 1. And 25 minus 8 is 17. That's not a perfect square, so that's not a solution. Negative 5. Well, if I had 25 minus 8 times negative 5, that becomes 25 plus 40, which is 65. Also not a perfect square. For 0, I would have 25 minus 8 times 0, which is 25 minus 0, 25. That's a perfect square. That might be our solution. And let's try 4. 25 minus 8 times 4, well, that's 25 minus 32, which is negative 7. Also not a perfect square. So it looks like C is what's going to be our value here. Now, if you don't remember the discriminant part, you don't have to worry. You could type all of these into your calculator. So I'll just show you 2. I'll show you for 1 and for 0 to show you why it works. So what I would do is type in to your calculator the quadratic equation. So you'd have 2x squared minus 5x. And instead of plus k, you would do, instead of plus k here, you would type in that a answer, which is number 1, so plus 1. If I graphed this, you could, we wanted 2 rational numbers. Well, if I traced the 0 here, I would see that the root's at 0.21. That doesn't look rational. That's why it wouldn't be one of my solutions. I'll just show you C to see why it works here. So for this answer, C was 0. So if I change that to plus 0, and I graph it, I should be able to tell here that my values, I have one x-intercept at 0, that's rational, and the other x-intercept is 2.5, which is also rational. Remember, terminating fractions. That's why it works. So if you don't remember the trick about discriminant, you can at least use your calculator because this is a calculator allowed problem. All right, those are the questions for Unit 7. If you have other questions, check the key on Canvas or ask your teacher for help.